For this question, we want to use the properties of logarithms to expand the logarithmic expression. Wherever possible, evaluate the logarithmic expressions. So the expression that we would like to expand is log of square root x over 1000 y squared. And the properties that we're going to use for expanding this expression are the product rule, the quotient rule, and the power rule for logarithms. So specifically, the product rule and the quotient rule are the ones that we consider to be expanding. The product rule allows you to take an expression that is multiplied and turn it into the sum of two logarithms. And the quotient rule allows you to take a quotient or division inside the logarithm and turn it into the subtraction of two logarithms. What I like to do is I like to use these two properties at the same time. And in the expression that we have, look for factors in the numerator and factors in the denominator. The factors that are in the numerator will have logs that are positive, and a factor that comes from the denominator will have a subtraction or minus sign in front of it. So the expression that we have inside of our log is the square root of x over 1000 times y squared. So when I look at this, I can see I have a factor, just one factor in the numerator, and then 1000 and y squared are two factors in the denominator. So because of these product and quotient rules, each one of the factors will get its own logarithm. Each factor from the numerator gets its own log, and each factor from the denominator gets its own log. So I'm going to be able to write this as log square root x minus log of 1000 minus log of y squared. So you'll notice that this factor of square root of x was in the numerator, and the log has no sign in front of it, so we assume it to be positive. And we want it to be positive because it's coming from the numerator. However, these two factors, 1000 and y squared, they were in the denominator, and so I have a negative on those logs. So those product and quotient rules have allowed us to expand that single logarithm into the log of each one of those factors. So this last property is a power rule, so it doesn't really expand into multiple logarithms, but if we have a power on an expression inside the logarithm, we can move that power to become the coefficient on the log. So we do have in this last term here, log of y squared, we have a power and exponent on that logarithm. So we're going to be able to use the power rule on that portion. But we also have on this first term here a radical. And radicals can be written as powers. This radical is a square root, and so we can write this as the 1/2 power. So we're going to write this as log of x to the 1/2 minus log of 1000 minus log of y squared. And with those powers, a power of 2 and a power of 1/2, we're going to apply the power rule and write this as the coefficient 1/2 log of x minus log of 1000 minus 2 log of y. And you'll notice one more thing that we can do in this sentence here. It says, wherever possible, evaluate the logarithmic expressions. This expression log of 1,000 is log of a number rather than log of a variable. The log of the variable we're not able to simplify because we don't know the value of the variable, but log of a number we can simplify. We have log of 1,000, so we say, okay, I'm not sure what this log equals. Let me let it equal p for power. Log always equals the power or the exponent. Let me rewrite this in exponential form. So to rewrite it in exponential form, I need the base of the logarithm, which is usually written right here. And since nothing is written, I know this to be base 10. We have 10 to a power equals 1,000. 10 to what power is 1,000? We know that power to be 3. 10 to the third power is 3. So I'm going to be able to evaluate that logarithm and say that it equals 3. And that changes this expression to be 1/2 log x minus 3 minus 2 log of y. I probably should have had equal signs all along the way, but we've now expanded this logarithmic expression using the product and quotient rule and the power rule. In addition to that, we've evaluated expressions where we were taking the log of a number to get 1/2 log x minus 3 minus 2 log of y. Thank you for checking out my videos. Have a great day.